Okay, let's solve another simple yet interesting problem. This is the arrangement. The entire surface is smooth. This block C is also kept on a smooth horizontal surface. B is kept on C and A is hung from the string. This is the arrangement of the system. Now the question is, if the masses of A, B and C are same, then what will be the acceleration of the block C? So the answer to this is acceleration of the block C would be g by 5. Did you get it? Okay, I hope you got it. The acceleration would be g by 5. And let's see, this is a simple equation. It has to do only with Newton's second law of motion. That's it. Let's one again understand how to go about solving this kind of problem. You have to write Newton's law of motion, and that's all. Let's write Newton's law of motion for the entire system, for all the blocks, pulleys, strings, everything. Now the force, net force on the entire system would be 0 in horizontal direction. There is no external force which is being applied, so the net force for the entire system in horizontal direction has to be 0. Now let's consider that this block is moving with acceleration c with respect to ground. Block B is moving towards left with acceleration b with respect to block C, not with respect to ground. So B, I am taking the acceleration of block B with respect to block C towards left, and let acceleration of this block A be small a with respect to block C vertically downward. Okay, now let's write Newton's second law of motion. Net force, Newton's second law of motion says net F external is equal to mass into acceleration of the system. Net external force is 0. That will be equal to mass into acceleration. Mass of C into acceleration of C plus mass of B into acceleration of B. Acceleration of B towards right, if you take right side as positive direction, is C minus B. You understand? B is the acceleration relative to C, and we are writing the net force. So that has net force will be equal to mass times net acceleration. So net acceleration would be the acceleration with respect to ground. So with respect to ground, the acceleration will be, you have C unit of acceleration because B will be going along with C. C unit of acceleration towards right and B unit of acceleration towards left. So that will make it C minus B net towards right plus mass into mass of A into acceleration of A. Now A is constrained to move in this well, in this rectangular well, and along with C, A will also move towards right. There's no option for A. So in horizontal direction, the acceleration of A would be the same as that of C. So mass of A into acceleration of A in horizontal direction. This should be equal to 0. Okay? Okay, then this gives us 3C is equal to D. So we have one relation between C and B now. And now again, let's write another Newton's law of motion for another motion in different dimension. Let's write the Newton's law of motion for acceleration of A and B with respect to C. Now with respect to C, A is moving downward. With respect to C, A doesn't have any acceleration towards left or right. With respect to C, block A is moving just downward. So let us write equation of motion for block A. mg is acting downward and tension is acting upward. This is the net force vertically downward. That will be mass into acceleration. Okay. Now for B, if we write, tension is the only force that is acting towards left, and that should be equal to mass into net acceleration towards left. Net acceleration towards left is B minus C. B is the acceleration with respect to block. Net acceleration towards left is B minus C. From here we get, if we add these two equations, what we get is G is equal to, and A is equal to B. From the relation of constraint, the distance by which A goes down, by the same amount of distance B has to go towards left, because the string is remaining taut all the time. So what we can do is we can replace this A by B. So what we're going to get is B plus B minus C. So this gives us 2B minus C is equal to G. And from here we have B is equal to 3C. So this gives us 6C minus C is equal to G, or C is equal to G by 5. Fine. So acceleration C is equal to G by 5, and similarly you can put C here and you can find B, and A is equal to B. So you can find all the accelerations. But that's how you solve it. You're writing just Newton's law of motion, and what you have to be cautious about is just this. When you write net force in one direction, that should be mass into net acceleration. Net acceleration. Okay, that's what you have to keep in mind, and just write Newton's second law of motion, and you write few equations considering few variables, and you have to solve those simple linear equations. That's it.